Hi.
Yeah, so this is really the first time that we've actually put these ideas in front of somebody like yourself, because we've been a good few years just getting the information ready and testing bits of it, checking the mathematics. There's lots of mathematics, but I don't want to do maths heavy videos unless people want it. Yeah, because you don't need the maths. So what we're going to do is we're going to stick with, number one, everything's going to be scientific. So I'm going to reference everything to scientific experiment that everybody can go away and check. Number two, I'm going to reference it to mathematical proofs that everybody can go away and check. Number three, all the information has to be internally consistent. That means it's like a crossword puzzle. You can't have something missing. If you've got something wrong, it doesn't fit with everything else. It's also got to be externally consistent, because at the minute, science is neither internally consistent nor externally consistent. What you see when you look out the window isn't the same as our descriptions of science. So I was just going to give you the standard way that I introduce this to people who would be, say, in industry, working on the problems of unifying turbulence with laminar flow, because they're not unified. It's the same air, so you can't have inconsistencies in science like that. So the reason I think this is going to work very successfully for systems people is that there's nothing else. There's only systems in the universe. And it's very clear since I've joined ISSS that a lot of information, a lot of scientific tools aren't available to people. And the reason for that is that the laws of chaos have not been understood by the science community. So they're pushed aside because everything that gets written about them is so confusing. You can't use what anybody's saying to your own benefit. So I'm going to introduce you today, Gary, to this book here, which should have changed history. But because the gentleman who wrote the book doesn't know what the laws of chaos are in fundamental terms, he can't bring the book to a conclusion.
What's the book?
Chaos and Nonlinear Dynamics by Robert C. Hilborn.
Okay.
I'm going to read some bits from it so you'll see that as for systems people, if you haven't got a good working knowledge of what's in this book, you can't understand nature. That's not an arrogant thing to say, Gary. It's just very practical, as you'll see, because these laws in here are all experimentally testable as classical physics. So it's hard science. And the laws are completely unexpected to science. We found them by accident with the discovery of just working with computers, Mandelbrot sets and things like that. Nobody suspected that there would be laws governing the unpredictable systems in nature. It wasn't suspected. And those laws have turned out to be universal. So they show up in every single field of science, from economics to physical systems, electrical systems, man-made systems. Doesn't matter. Laws of chaos show up. So I'm just going to go through the PowerPoint just to show you we really have to slay the dragon of tradition today. So this is Western tradition. If we were to name the most powerful assumption of all, which leads one on and on in an attempt to understand life, it is that all things are made of atoms. Well, we all agree on that. So there should be common principles at work. And everything that living things can do can be understood in the terms of jiggling and the wigglings of atoms. Now, I don't agree with that at all. And I think a systems person would say, the whole thing about systems is correct me if I'm wrong, you can't look at the bits on the table and say what they're going to do when they're behaving as a system. So that's gone. This is the traditional reductionist view, which has been holding back science, specifically Western science, because if you go over to Asia, there's a completely different mindset and philosophy of science. They think in paradoxes, where they're seen as necessities, we see them as contradictions, and they see everything as just driven by mathematical rules. We're still hanging on to fundamental forces. So let's see if we can slay the dragon of tradition. So here, everything is made of atoms, but in scientific terms, it has been a failed endeavor. Physics was supposed to explain everything else, but has turned out to explain nothing else. Worse still, physics has split into two inconsistent parts, so it cannot even explain itself. We must all be making a fundamental error, which we have become very comfortable with. Every university department studies the same matter, but the study of atoms does not explain the motion of anything at the classical scale. Classical mechanics and quantum mechanics do not explain the motion of three bodies in space. How simple a system is that? A chaotic pendulum, turbulence, a snowflake, genetics, a virus, or anything in biology. So we need a complete rethink of how we look at reality. We need to think free from culture, traditions, and norms. So we have all the pieces of the puzzle, that's for sure, but we're not analyzing them correctly. Professor Lee Smolin. So a lot of this isn't generally known, Gary, that a snowflake is not understood by science. So I've got to prove that to everybody, not using my words, but a particle physicist explaining why that is. And then I'm going to put all the science back together by the end of this little talk. It's all going to make sense. The problem is that just seeing logic doesn't mean a human brain can accept the answer. Logic by itself doesn't do it. If it's important, what the brain wants is fame, fanfare, and ceremony. And I've got none of that. I've only got logic and evidence. So the traditional viewpoint from the West that physics was going to do everything for us hasn't been a successful endeavor. So this is when it really starts to fall apart. So according to Einstein, gravity is not a force. So if we've thrown out gravity as a force, it's got to be replaced with something else. And that something else has to be compatible with all the other parts of science. So the answers in front of us here: a sphere has positive curvature and a gravitational field has negative curvature. Well, that's mathematics. It's space and time, space and matter following a mathematical rule, which is all that quantum mechanics is. So this is another very shocking picture. A chaotic path mapped out by a single planet orbiting two suns. I've only got three entities in the system, and Newtonian mechanics has gone. It's completely collapsed. You've got to look at that picture and think, that's it. Whatever physics was, we've moved on to something else. So it's statements like this. This is the mathematician Ian Stewart. So if you look at the last sentence, science now says the solar system is chaotic, but we know it isn't. We know that parts of it are chaotic. So the moon of Saturn Hyperion wobbles chaotically on a classical orbit. So some bits are classical, some bits are chaotic. But we can't just make statements like the solar system is chaotic without saying, hang on a minute, that doesn't make any sense. So this is particle physicist Frank Close talking about the theory of everything. He says it is possible that this will eventually prove to be the long sought after theory of everything. He's talking about superstrings. And to read some popular science or watch it on TV, you might have the impression it's established law. However, there is at present no clear evidence to show it has anything to do with the physics that's been revealed by experiment. That is a shocking statement from a physicist. Nothing to do with the physics that's been revealed by experiment. So something's wrong at a very, very fundamental level. So this is just to prove to people that a snowflake can't be explained by physics, because in a lot of BBC programs, the scientists imply that it can. So he says, for example, molecules of water are free to take up any direction within a warm liquid. But once frozen, they form beautiful structures as exhibited by snowflakes. A pattern emerges in the cold, even though the underlying laws show no such prejudice for one direction over another. That's it. So physics as the be-all base set of laws for everything else, that one's done. So we've got to replace physics with something else. So here's Roger Penrose, who says, do we really need to move forward to radical new theories of physical reality? As I myself believe, for the more subtle issues of biology, most importantly, conscious mentality can be understood in physical terms. So when Roger Penrose is saying we need a new theory of physical reality, the game's up for the old way of thinking. And there's lots of books, Gary, like this, Trouble with Physics, that's Lee Smolin. How the laws of physics lie. That's not true. The laws of physics are all correct. They're just not enough. Bankrupt in physics. How today's top scientists are gambling away their credibility. The end of physics. And this gentleman who we really like, Stuart Kauffman, The World Beyond Physics. So everybody's calling for something new. So we just have to step back and start again from scratch. So I've put down some axioms here to guide us to a new way of thinking. Quantum mechanics is all correct, and proved by experiment. Classical mechanics is all correct, and proved by experiment. Chaotic mechanics is all correct and proved by experiment. At present, these three fundamental kinds of behavior are inconsistent with each other. Scientific information must be internally and externally consistent. So what I'm going to do now, Gary, is to put on the table an alternative based on logic and science. So if I look on quantum physics, there's no fundamental forces, just the exchange of information via bosons. Classical physics, which needs a change, because if gravity's gone as a force, and if a gravitational field is not a force, how could it be? How could an empty space apply a force to a planet? And the magnetic field's gone as a force. And this book here, Chaotic Mechanics, where he states physics is not appropriate here. We need a new level of explanation. So if I look at what is guiding these systems of nature in this book, there are only mathematical equations. There's nothing else. If I look in the quantum mechanics book, there's only mathematics. So Jim Al-Khalili says quantum mechanics is matter following mathematical rules. If we say that classical physics is matter and space following mathematical laws, we've then made them consistent. We've got three different kinds of mathematics. We've got quantum mechanics, which is arithmetic, classical mechanics, which is geometric, and chaotic mechanics, which is fractal. And mathematics is self-consistent internally. It's the only field of science that is. Some people say it's not because of Gödel's incompleteness theorem, but that's not true, because incompleteness means incomplete, not inconsistent. So quantum mechanics is matter behaving to mathematical rules. Chaotic mechanics is matter behaving to mathematical rules. Biology is matter behaving to mathematical rules. Mathematician Ian Stewart, the structure of DNA is deeply mathematical. Classical mechanics is driven by fundamental forces, or was, but gravity has already been thrown out as a force. General relativity is the geometric theory of gravity. Well, surely geometry is what you study in the maths lesson. Now, I'm not the only person saying this, Gary, because if we look at Ian Stewart, The Mathematics of Life, Mario Livio is God a mathematician. Alexander Unziker, The Mathematical Realist, The Mathematical Brain, Brian Butterworth, and The Universe Speaks in Numbers. So what I'm going to do now, Gary, is to take us on a journey of just proving that that has to be true. The universe is driven by mathematics. So just to show that it's not me that says gravity is geometry, it's very, very well-respected mathematicians. So here's some axioms to guide us. The universe is only made of systems. So the simplest system would be the proton, which is a system of 3 quarks and gluons. All systems are made of the same matter. Therefore, all systems must have common principles. If the universe is governed by mathematics, then the building blocks of mathematics and the building blocks of matter must mirror each other. So that's what I've got to show today, that they do mirror each other. The building blocks of the number system are prime numbers. So we should look to the formation of matter to see if there are common principles between primes and the formation of the elements. So here's a nice quote by Brian Cox telling us what to look for and where to look. He says there's a mystery at the heart of science for which of yet we have no explanation, and that is this universe is simple. Underlying all the astonishing complexity appears to be a magnificent simplicity, and nowhere is that simplicity more obvious than in the construction of the elements. So what we want to see, Gary, is that mathematics builds itself uniquely from prime numbers. Every number is completely unique in the universe, just as unique as an element. We want to see a mirror image between the formation of the elements and the formation of composite numbers. So here I've put together, this is proton-proton chain in the sun, forming the first composite element, helium. So as you can see, it's all pairs and triplets, which are the first 2 subprime numbers, 2 and 3, which build everything else. So deuterium, 2H, and tritium, 3H, go on to build the first composite element, which has 4 nuclear particles, and the first composite number is 4. And if you give it 2 electrons, the second composite number is 6, and helium ends up with 6 particles. So we do find a one-to-one match between the formation of composite numbers and the formation of composite elements. Now, I'm only giving you one example here, Gary. I've got hundreds of them all shown, but I don't want to overload you with information. Now, this is particle physicist Frank Close. He sees there's a profound parallel between quantum electrodynamics on the left and quantum chromodynamics on the right. But he doesn't know what it is. So if we assume it's going to be based on prime number patterns, we can then rearrange the standard model according to prime numbers into something that is self-consistent. The periodic table is internally consistent. The standard model is not. So if you rearrange the particles in the standard model into the prime patterns, you do find it comes out as a consistent model, everything as pairs and triplets. So when Frank Close says there's a profound parallel between QED and QCD, when it's presented like that, you can see it. There's a pair of properties, positive and negative, which join up with the triplet of properties. And in the quark, I've got a pair, two up quarks, and a single down quark. So this pair and triplet, a related pair with a unique partner, does fit with what we're saying. I'm not the only person to have seen this. This is from a book on particle physics. The triplet, in fact, could be thought of as a kind of building block for the larger patterns. If the octets note relationship with music as well coming into play, and note the pair and triplet on black keys on the piano and the octets, the very logic of mathematics, not physics, seemed to demand that these patterns be erected atop a foundation that had something to do with the number 3. So this was taken by somebody talking about the Eightfold Way. The Eightfold Way, and I'm glad that you are quite happy to use Chinese philosophy, is based on prime numbers, and it was used to rearrange particle physics in the 1950s, and it worked. And nobody said, stop, how can that possibly be? And because it was somebody famous doing it, everybody just accepted it. So we're looking for these pairs and triplets, and we want to find them in biology. They've got to be there. So DNA is based of pairs, T and A, and notice they can swap into each other, just as the quarks can swap into each other, just as the proton and neutron can swap into each other, a diversity switch. And the case illustrated is for a code with 3 letters, a triplet code of information, which is what you see inside a proton or an atom. So we now have 108 examples of these pairs and triplets at the base of systems in nature. Everything from economics to music to art to language, to viruses. You just keep noticing more all the time. So animals, plants and fungi, eukaryotes. Animals and plants are not seen as a system, but they are, because photosynthesis and respiration are a mirror image of each other. And if you had a world which only had plants, the air would just become more and more oxygen rich until it killed everything off. So you've got to have them as a system, and fungi is the third unique partner. So that pattern that shows up very clearly here. So even the charges come as a related pair and a unique partner. Means that you can now put the fundamental laws of nature, or the 3 different kinds of mathematics as a pair and a triplet. So on the bottom left, we've got quantum mechanics. The bottom right, classical mechanics. And at the top, the unique partner, chaotic mechanics. So now you've got 3 different kinds of mathematics arranged as a related pair and a triplet, which allows for all the unpredictable parts of reality, the predictable parts of reality, and the probabilistic parts of reality. So now we're going to use that to sort out the big problems that we have in physics. So this simple chart here shows that classical mechanics and chaotic mechanics actually work at the big scale, the macro scale, as a partnership. One explains the completely predictable, the other explains the completely unpredictable, and together they produce the predictable logistic maps, which you see, which is systems that go in and out of order and chaos, which is what you would expect if you had systems built from a mixture of classical and chaotic physics. But there's a complete change where the arrow points to that line. 2 bodies in space is classical physics. 3 equal-sized bodies in space are completely chaotic. The classical physics has collapsed into something else. It's been overruled, but it hasn't gone away. 3 bodies are still moved by gravity. But now what you can see is that that has become a mirror image of exactly the same thing happening in quantum mechanics. The Schrödinger equation, which is completely predictable, when you try and take a measurement, it collapses. And you can't say where a photon or electron will arrive on the detecting screen until it actually arrives. But the wave function, the completely predictable part of quantum mechanics, collapses into something that's unknowable. That is seen as a problem, but now it's a necessity so that the quantum realm is working on the same principle as the classical realm. And this also now has to show up in the complex realm, which I'm going to say is biology. Asexual, completely predictable, a single outcome, which is identical to the parent, a clone. And we go over to sexual behavior. It's completely unpredictable and has to be so. Otherwise, you don't get a 50-50 distribution of males and females, which is never complete. But you need to get that 50-50 distribution from something which must be, by its nature, completely unpredictable. A 50-50 chance of getting male or female. So it not only solves these problems I've put on here, it also solves big problems in mathematics, P versus NP problems, polynomials, predictable, non-predictable, non-deterministic polynomials, and then non-deterministic polynomial complete, which has this mystery that once you've solved one of them, you can solve them all. Now it's not a mystery anymore because you've got the lot in the third column. So hopefully that's not been too much of a shock to the system, Gary, but it's all logical. And there's an awful lot in this book which is just missing from universities because the book is too difficult to understand. You can't make head nor tail of what you're reading. But he keeps saying throughout the book, this is deeply profound. And one day, the laws of chaos will be seen as important as the laws of quantum mechanics and the laws of classical physics. So he makes predictions in the book. He also says that one day, the Feigenbaum constants of chaos will sit beside the fine structure constant in physics. He states that quite clearly. So we've now got those two in a single equation showing how they are related. I didn't do that mathematics. It was done by a gentleman called Tim Hopper, who's a natural, very gifted mathematician. So this is a completely new way of looking at things, which puts chaos, it brings chaos in from the cold and puts it on the table as important to understand systems as anything else in science. You can't do without it because chaos shows up in every single field of science. And it's the contact with the experiment, which is what people really like, because that's how we know it's science. I don't know if you remember cold fusion, when everybody tried to go away and do the experiment, it didn't work. So in a week, it was gone. I'll just read you a quote from the book, actually, Gary, just to show you. So the second chapter in the book is called The Universality of Chaos. He says, it's difficult to overstate the importance of these universal features. If each non-linear system did its own thing in its own way, then the study of dynamical systems would have languished as a branch of applied science. These features include a sequence of bifurcations connecting regular periodic behavior to chaotic behavior. These features are largely independent of physical, chemical, or biological details of the system. That's a very, very powerful thing to say. This universality has made nonlinear dynamics a truly interdisciplinary field of study. And then further in the chapter, he says, we should reflect on this agreement between theory and experiment, bedrock science. We should feel a sense of awe and wonder that there is some quantitative link between experimental results and a simple mathematical iterated map. In a traditional physics setting, if we see some common quantitative and qualitative features in the behavior of different systems, we look for some common underlying physical cause. It should be clear, however, this kind of explanation is not appropriate here. So there's no physics in the chaos book. There's no chaos in the physics book. They are separate fundamental laws which do not emerge from anything underneath. Chaos is as fundamental as classical physics. It doesn't emerge from classical physics, but a lot of people think it does. They say, oh, it's just systems which are very sensitive to initial conditions. But that's not true, because if you put two identical systems into a computer, they still end up doing different things. So it's just been completely misunderstood, and it's all been held back by the fact that we don't see physics as matter and space being driven by mathematical instruction, or mathematical guidance, if you like. I'm not saying, Gary, I'd like to know what you think about it, that it's actually causality. It's like the game of chess. The causality is what's happening in people's heads, but they have to follow mathematical rules. So it's just saying that everything has to follow these rules. They're forced to follow the rules. So that's really what a force now has become. It's just forced to follow mathematics. So it's a completely different way of looking at things, which if you give people the right examples, they can all make up their own mind and say, well, the periodic table and the standard model are now consistent with each other because they both follow the prime number pattern. That had to be shown to be true one day because the standard model doesn't make any sense. But you've got 3 pairs of quarks and 3 pairs of leptons. So there's an awful lot of information there, Gary, to take in. And you won't be able to remember it all, but you seem to be able to follow it step by step as logical. Yes, that A plus B equals C. B plus C equals D. So I only finished this yesterday, but hopefully it can be followed.
Yeah, no, it was all fine to me.
Brilliant.
But I think you probably hit on an audience who was already receptive.
Well, yeah. That seems to be the case, because when I try and give this to old physicists, they all do the same thing. They won't comment and they walk away in silence. It's just too much. In fact, one old gentleman left the room in tears which wasn't the intention at all.
No.
And he got back to me and he said, I can see the logic, but I can't accept it. And that's just the sociological part of your brain saying, I want tradition, I want culture, and I want norms.
Yeah.
If you just throw them all out the window, that's going to hurt somebody.
Yeah. Yeah. You go back to slide 20. So what I'm trying to do is I'm trying to make some connections.
Yes, yes. No, this is good that you're asking questions, Gary. It's just what we need. Yeah.
So when I look at that and analyze it, I can see a direct relationship with relational theory.
Right. Yeah.
And are you also familiar with the Kinefin framework?
No.
By Dave Snowden? Okay.
No.
Right. So I was aware of Dave Snowden's framework for quite a while. Let me see if I can find it first. Well, let me just explain the story. So Dave Snowden's framework, it has essentially 5 main parts to it. So it's made up of quadrants, but there's also a center part. So the center part is either it's essentially disorder. Center part is essentially disorder, right. And it's a sense making tool that he developed at IBM, and it allows people to understand where they are in terms of a situation and how to deal with the situation most effectively. So you have disorder in the center, which is basically I don't know where I am. Yeah.
Right.
And then there's perceived chaos. There's perceived complexity, perceived complicated, and the perceived simple. Yeah. And I can relate those different quadrants to the different quadrants that you have here. Yeah.
Right.
So you've got a simple area, which I guess would be the rigid laws of physics part.
Yes. Yes, absolutely.
Yeah. You've got the perceived chaos, which is the top right. You've got the perceived complex, which is top left. And then you've got the perceived complicated, which is the bottom left. Yeah. So the perceived complicated is the domain of essentially experts. Yeah. So they know everything about their subject, and in an area which is complicated, the expert can work out cause and effect. Yeah.
Right.
So that maps quite nicely to Dave Snowden's framework. But also what I then noticed with Dave's framework was I could see the direct relationship with relational theory, the relational model. Yeah. And the relational model is essentially, so in the center, you've essentially got things in the universe, yeah, and they're the source of signals. And the perceived chaos area is basically where you have informational events, and then informational events then lead to in this format here, the self-organizing systems, the knowledge frameworks. So information, when it's structured, becomes knowledge. The knowledge structures then provide enabling constraints for forces. Yeah. And when forces are applied, they manipulate matter and energy to create new things or transform things. And the relational theory all came about from Robert Rosen, who was looking at how living systems work. But later it was recognized that this pattern was related to all systems of any type. And it connects really nicely with quantum physics, with information science, etc., etc. So this pattern, which you've also described in this framework, was not a surprise to me.
Right.
I could see how it connects to other things. Now, it's not accepted yet, but I see relational theory as essentially a foundational theory for all systems. And it ties in with what you were showing here. But the other nice thing is that the Kinefin framework is very well understood and recognized by system practitioners, particularly in systems engineering. So if we can make the connection with your stuff, with the system science stuff, and really get that recognized as foundational, we then have the means of communicating it effectively to engineers who are doing all of this system stuff.
Right. Because I think, Gary, what you just said all these systems work needs is bedrock scientific foundation, which
Yes.
you can now see we can do that.
Yes.
And
Agreed.
that's what's really going to give everybody credibility in what they're doing, is that once you can see that all systems are based on these prime number patterns, and we've got 108 examples of that.
Yeah. Yeah. And it's also referred to in the Tao Te Ching as well. You know, the one
yes.
becomes two, becomes three, becomes the many things.
Yes. Yes.
Yeah.
I'm glad you mentioned that, Gary, because I actually went to live in Taiwan to work all this out.
Yeah.
Because I realized that Western thinking at the time, this is 20 years ago,
Yeah,
was too stuck in tradition.
Yeah. Well, largely it still is.
Yes. Yeah, I was very pleased when I went to Hull University and met with Gerald Midgley, how welcoming he was to new ideas.
Yeah, I know Gerald as well. He's a good guy.
Yeah, it was just so pleasant for me to sit there. He didn't know me from anything, and he went through it and he was able to talk about it, and he wasn't shocked. He didn't get upset or anything like that. It was just like, well, yeah, this seems to make sense.
Yeah.
You've got some information which we have been missing. Basically, because all the books on chaos are too difficult to understand. You can't make any sense of them because the people who are writing them can't bring them to a conclusion. And that's the problem, because that book, Gary, I highly recommend to you, because it's packed with gems of information.
Yeah, I'll take a look at it and see if I can. I mean, I have an appreciation for maths, but I can't. It isn't a natural language for me, you know.
It's not for me. It's not for me either.
Some people can look at equations, you know, and it immediately has a visual meaning for them.
Yes,
it doesn't work like that for me.
No, it doesn't work like that for me. But you'll find that the book has enough. Just in what's written in the book is more than enough. And because it's such a difficult read, my working partner, who's this gentleman here, there he is. Is that?
Do you want to stop the presentation? And I'll stop the recording as well, if that's okay.
All right.